So thank you all for coming tonight. I have a lot of material to cover, and my biggest problem is I don't have enough time to do it, and I don't want to waste your time by talking about other items that you don't care about. That's a really arrogant statement, isn't it? I seem to suggest that I had possession or owned time as if it were something I had. And then I also projected against you all that you all actually owned your time as well. And hopefully at the end of this, I'll tell you a bit about the format first, but I have some pictures here. The astronomical clock, which is in Prague. I don't know if you all have seen that before. 1410, it's the oldest working clock in the world and the third oldest clock period. Here we have a sundial from about 1500 from Egypt, the oldest timekeeper ever that we have. And then we have an atomic clock, which now they're tiny, accuracy of about 1 second in 135 million years. And then when we think about time, what we have is this. We have an hourglass on top of a tombstone reminding us of where we're all going to go. And hopefully we can think about what we ought to do before that. So I'm going to sit down and I'm going to read a little bit of a partial meditation that I wrote a while ago to set the tone. And then I'm going to go into the talk, which is mostly not reading. We all think about time. More than likely, you set your alarm last night to get up at a particular time this morning. After you woke up, you had to get ready for your day and had a limited amount of time in order to do it. On many occasions during the day, you had to synchronize your schedule with that of others. This could be in the form of getting kids ready on time for an event, showing up at a meeting at a particular time, completing a task on time. But more than likely, all of the above and more. The funny thing is that when we were born, we were not aware of time at all. Our parents made certain that we learned of its existence early on as we became integrated into society. If they hadn't done so, our lives would be a mess. Have you ever noticed that humans are the only creatures that teach its young about time? Why do you think this is so? All of us, no matter who we are constantly thinking about time. We've all heard that time is such an important commodity. Sure, time is valuable, but no matter who we are, we only have a limited amount. But a commodity? Probably not. You can buy a commodity. And we've heard the term buying time, but time is one of the few things that we cannot purchase at all. However, we can invest our time. Still, we all use it up at the same rate. Sometimes it flies, as we often wonder where it went. As a physicist, I was trained to be fascinated with time. What is time? Why does it always go in one direction? Why is it that progression of time never changes for you, but it can go more slowly or quickly for another person relative to you? Why can't you stop or reverse it? Is it possible to have two timelines? Why can't time be accumulated or stored up? The list goes on. Thinking about time from a physics perspective can be interesting. For most of us, our interest in physics generally doesn't progress much beyond the 2 hours we are watching the latest science fiction movie. So I've studied physics for about 30 years. Still, no matter what I do or what I learn, I can't do anything to change time. In that capacity, continuing to study time from an academic perspective borders on the pedantic. In contrast, meditating on the spiritual aspects of time can be far more rewarding than studying it from the physics perspective, for the solitary reason that there is something substantive that we can do. Okay? So a little bit of an outline. I try to be all things to all people because everyone here has a different background. So hopefully there'll be something, a little nugget you can latch onto. So my goal is that there'll at least be something here you haven't thought of. So initially we're going, because I'm a physicist, I'm obligated to talk about it from a physics perspective. We'll talk about that. And then we'll go into how is time. So I kind of fooled you all. I titled the talk, What is Time? But that was just to pull you in. And then we're going to talk about the more important question of why is time. And then I have a little meditation at the end. So to begin, so you ask a physicist, what do clocks measure? Or you ask a physicist, what's time? They say, time is what clocks measure. And then you say, okay, what's a clock? Yeah, well, that's easy. A clock is what measures time, you dummy. So you're going to find a lot of circular argument in from the physics perspective because we don't really know. Okay, now we're done. Let's eat. So let me give you an example of some things that you think are really obvious and they're not. The concept of now. So sometimes I'm a timer for the swim team for our kids, and we'll all be timing our stopwatches, and we'll all do that. Well, okay. What happens if you're really far away from someone? You know, when we have our Mars rovers, they're an average of about 12 minutes away as far as the speed of light goes. So if something happened there, we don't even know it for 12 minutes. And if we want to send a command to it, and it does it, and then sends it back that we got it, it's 24 minutes. So that's why we have to have a lot of autonomous systems for the rover, because a lot can happen in 24 minutes. But what does now mean? It now for them and us is not really the same, because you have to be able to somehow communicate that okay, now. So one thing about past, present, and future, if you have a bunch of particles in a box and they're bouncing all around elastically, it's funny, you can actually look at that in reverse and you can't tell the difference between time going forward or time going backward, which is very unsatisfying, by the way. There is a famous quantum physicist named Julian Barber. He says time is just an experience, and it's related to how we experience it. Well, that's a bunch of bull. That doesn't mean anything to me at all. That's not very helpful. Now, there is a little nugget that can give you a little bit of satisfaction. We're going to talk about that later. Time appears to flow in one direction. We do something that causes this. We never see the opposite of that, where the effect causes the cause. That never happens. Okay? So the obligatory things, and you all have heard of this before, but I'm going to say it again very quickly. About 100 years ago, Einstein, he had two little postulates, and all of special relativity came from that. He said, if you're in a train and there's no windows and it's moving at a constant velocity, you can go about your life and do everything you ever wanted, and you can't tell you're moving. We can sit here, we're not moving, someone's moving really quickly by us. Each of us can't tell that we're moving relative to each other. They're going fast compared to us, we're going fast compared to them. Each of us thinks we're stationary. And then the other thing, other postulate, speed of light is the same for everybody. Whether you're going fast or standing here, speed of light, same. Well, in order to rectify that, if you, for example, had a flashlight and you're going really fast, like half the speed of light, and you turn it on, well, it still goes off with the speed of light. And the only way you fix that is you say that time changed. Okay? So what happens is that when things go really fast, time will be slowed down and space is contracted. So I purposely did not put any equations up here, but that's basically what happens, and that's all of special relativity. Now, if you you're accelerating or you're in a gravitational field, like by a black hole, it's really noticeable. Time slows down for you, okay? And a famous example of this is the twin paradox. You have two twins, and one gets on a rocket ship and takes off and goes half the speed of light and then comes back. Well, the first one says, well, you're going really, really fast. I think your time is going more slowly for you. And this one says, well, even though I'm going away, I think that you're moving away from me and time's going more slowly for you. So each of them thinks the other one gets a lot, doesn't age as much. It turns out the one that comes back ends up aging a whole lot less, and you actually have to have something called general relativity, which is basically how time works when you're in a gravitational field or really a lot of acceleration. So like if you're really close to a black hole, you don't age much. You probably saw that in a movie, although you'd probably be ripped apart by the gravitational forces. So all these things, kind of neat and fine, but it doesn't really say what time is at all, okay? So I have to ask all of you a question. Where did you learn about time travel? Well, if you're an old person, it's going to be Star Trek probably, right? And if you're a really young person, it's going to be Marvel. If you're English, it's going to be Doctor Who. And if you're my age, you're going to think it's Bill and Ted. I probably should have put Back to the Future in there too. What was it, Mary?
No, it was Star Trek.
Okay, me too.
Next generation.
So guess what? All of this is a lie. So, but I don't, hopefully that won't ruin it for you. It doesn't ruin it for me. I've seen all the Marvel stuff with my kids. They love it. So do I. So what about stopping time? That happens all the time in these movies. Sorry, doesn't happen. Sounds good though. Traveling back in time. No, you really can't. Traveling to the future? Well, about as hard as traveling back in time. No. Multiple timelines. No. In equations, some of these things, parallel universes and multiple timelines, they say it might be possible, but there's really no way of verifying it at all. So it sounds fun, but practically speaking for us, just keep watching Star Trek, okay? So now, one of the things that people ask, well, is time real? I just told you what Julian Barber said, and it wasn't very satisfying at all. Well, physicists say something's real if it's a necessary ingredient of a theory that correctly describes what we observe. Well, for special relativity and general relativity, yes. The answer is yes, it's very real. Quantum mechanics, you need to have time also to describe it. The problem is they don't agree with each other. Yes, sir?
I'm sorry, you're picking out general relativity and quantum mechanics because those are the two most fundamental working theories that physicists have right now?
Yes.
Okay, thank you.
And you're going to probably know more than I do because you had this stuff more recently.
Well, I didn't want to say that.
So the problem is that they've been trying to work since I started graduate since the 50s actually, before I was born, try to have a theory of everything. They don't have it yet, and there's not yet. Maybe it would be you, Francis, but so we use it in general relativity, and we use quantum mechanics piecemeal. Okay. So now, most physicists believe that in the Big Bang, we've all heard that, something, and here's what it is, because it's really not very satisfying. There was nothing, and then all of a sudden something exploded, and that's the universe. And it's constantly expanding and constantly cooling at the same time. And it's really kind of funny, because when I was researching some of this, what you hear about what physicists believe with the Big Bang kind of sort of sounds like what you read in the Bible. They actually use the word term outside of time. And they say that time did not exist at the beginning of the universe. just like Genesis says, which is kind of interesting. So, okay, now we're going to get to something a little more satisfying. And you'll like this, Francis. There's a video by Steve Mould who actually talks about this. This is really cool. So, theory of everything pretty far away. Time goes in one direction preferentially. And so, one way to think about this, I have a picture of a glass of water and someone dropping some ink or food coloring in there. Now, when you watch that happen, you know what's going to happen. Eventually, it kind of equilibrates, and it's one uniform color, right? You have never seen it start from being uniform and all gather up and go into one little drop on the corner. You've never seen that before. Another example, if I have a box and it's a vacuum, and I put a little bit of gas or air in from one corner, we all know that within a pretty short period of time, it's all going to be equilibrated, and there's going to be a certain amount of pressure in that box. And it's going to be the same on all sides. Another way to look at the same problem, imagine if I have a box with a bunch of ping pong balls in it. And it's got a whole bunch of layers. It's full. It's square. And the bottom layer, I paint them all black. The rest are white. And then I shake them all up. Well, when I open that box, who here thinks that you're going to have a bunch of black ones on the bottom? We all know that doesn't happen. So here's an interesting way to look at it. Each ping pong ball can, think of all the configurations of all the ping pong balls and how they could be. What looks random to your eyes, there are zillions and zillions and trillions and gazillions and googles of configurations that look kind of random, but only one configuration where they're all on the bottom. So if they're all bouncing back and forth and going all around like molecules of gas in a box, or ink particles bouncing all around in the water, if there's only one configuration where they're all on the bottom, and zillions the other way, and they start off initially in a certain configuration, it's highly unlikely they're going to be back there again, because you have zillions and zillions and zillions and zillions of other configurations there. So entropy is so people like Francis and I were taught that's a disorder of the system. And that's super unsatisfying to me. It sort of says how random everything is. And one explanation, I think we should pray. So imagine the whole universe being pockets of energy that are concentrated in various places. You could have if those were candles, those would be hot. Okay, so you would have energy contained in the candle, and it's burning, and then that heat will spread out. And we have pockets of energy all around our universe, and they're constantly spreading out. You're a heat engine. You eat, you get hot, and the heat just goes away.
Small clarification question.
Uh-huh.
The non-physics person. Does that mean that there's pockets of non-energy or
I would say it's more energy and less energy.
there's energy produced throughout the entire universe. You just have pockets where it's more concentrated than others.
That's probably a good way to look at it. In fact, what physicists believe is that eventually someday, a really, 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 really long time from now, everything will be equilibrated and everything will be the same temperature, a low temperature. And that's called heat death. Now, if you're thinking about time, it's interesting. I didn't quite have time to go into this, but I wanted to. So I'm glad you brought this up. So you can really only tell the passage of time when something is changing. So one way to look at the end of the universe is that time will no longer be progressing because everything will be the same. Kind of like the beginning of the universe. So that's the only way we can actually tell the progression of time is if something is changing. So you have the whole concept of entropy came about in the Industrial Revolution, where they had heat engines, and they found out there was a limitation to how good a steam engine could become, and we find out that's that way with all types of engines. And what we do is we take a source of energy over here and use it to do something over here. And every time you do that, you're basically spreading out energy more and more and more in the universe. So eventually, everything gets spread out. So I don't know if that's satisfying to you all or not, but it kind of made me feel a little bit better. So changing gears here now to how time, okay? You all know this, probably recognize this is Fred Flintstone. Did you notice he only has 3 fingers?
I noticed. They all have 3 fingers.
So what do you need to measure time? And this is one of the more interesting parts of the talk. Synchronization. And you say, what's that? Well, in order to synchronize 2 things, you have to say, I'm going to have an event. And an event requires 4 coordinates, x, y, z, which is space, and time. And a practical example is meet me at the coffee shop at 4th and Main at 8 a.m. And the 4th coordinate was z, because you're probably not flying. You're just going to be on the ground. Okay? Synchronization is done all the times with computers. I know you have asynchronous computers, but in generally computing, you have a lot of things going on, and they all have to be timed appropriately in order to get what you want. So it's a whole bunch of entities agreeing to each other. Okay, we're going to do this now. We're going to do this now. We're going to do this later. We're going to do this later. So we actually have to have the ability to measure time. So, but in order to measure time, you need to have an oscillator. And an oscillator is, the best way to say is something that goes back and forth, back and forth. And when it goes from one state back to the same state again, we call that a period. Okay, enough with the mumbo jumbo. I'll give you 3 oscillators that we've known about for a really, really long time. Sun comes up, sun comes down. That's a day. We all know about that. It's always a day. Moon comes up, comes full. Not a moon, full again. That's about a month. It's 28 days. The Earth goes around the sun. That's a year. And those are great oscillators. We use them all the time, and to this moment, we still use those terms, and they're very, very useful to us. So we can say, okay, I will meet you in 3 days, right here. We've agreed upon, the system of timekeeping. Okay, so now they began to split the day up into pieces, and the sundial was the first example of doing that. So I gave an example of periods that were pretty long. We had a need to have much shorter time periods. So a sundial was initially used for that, and also mechanical clocks. They were used for monks and monasteries to know when they should pray. And I believe, and since I never took Latin, is that pronounced clocka? Okay, I knew you would know. So Latin word for bell. So these early clocks they had, which about 1270 was when they first started making mechanical clocks. They would use them to ring a bell and let everyone know when it was time to pray. The first clocks were made in southern Germany, northern Italy. between about 1270 and 1310. So there's all kinds of neat technology. I invite you to look some of this up if you can. You all have heard of Christian Huygens, Dutch mathematician and physicist. You'll probably think about him and doing the microscope, right? That's what he's known for. But it turns out he was a genius for clocks. And he is the person that invented the pendulum clock. Wow. Before that, they had weights that were pulling down. The pendulum clock is great. And we always talk about the period being the same. It's square root of G over L. Well, it's actually not. but he figured out some mathematics to actually make it so if it actually traverses a cycloid, which is a special shape. And he increased the accuracy of a clock by a factor of 60. And this guy was a dude. And made them to where they actually could be used practically. They lost only about 15 seconds a day. Pretty good. It's a long time ago. So again, time measuring, it has to be consistent. So if I have a clock, it's not much helpful. If I have a clock and you have a clock, and we can synchronize and we can talk. So it has to be consistent. So now, lots of technology development has been driven by military technology, and this is a great example of that. But first, and it has to do with navigation of ships. And when I think about navigation of ships, I think about this painting, and it's one of my favorite paintings. This is by Rembrandt, Storm on the Sea of Galilee. It was in the Elizabeth Stuart Gardner Museum in Boston, and I used to go and see this thing all the time when I was an undergraduate. And it, along with several other paintings, were famously stolen in 1990. So you can't see it anymore. And they've been stolen for 30 years. And this is the one I always went to. And it wasn't the most famous one that was sold, but I just loved it. And the apostles, like one of them, you can actually see he's throwing up. And it's just beautiful the way he used light. Anyways, so 1707, 4 British warships off the coast of Cornwall, the Scilly Islands. They ran aground. 2,000 men died, including the big guy, the admiral of the fleet. It upset the British government so much that Parliament gave a 20,000-pound bounty for anyone who could solve the problem of longitude. Yeah, you thought I was going to say longitude, right? Well, the British say it longitude. So I'm going to say longitude to be proper, but also it'll slightly annoy you all when I'm saying it.
Why was this a problem? Why was the current technology not working for fleets?
So it turns out that back to, if you want to know where you are for navigation, you need to know longitude and latitude, X and Y, north and south, and east and west. And we can use the sun and we can use the stars to tell us where we are for latitude. The sun is great. We know you can see the sun generally every single day. It reaches a certain height based upon your latitude at its peak at noon. And exactly, you can use a sextant, which is a little double reflection device. You can actually see exactly how high it is in the sky. And you can see it on a moving ship when it's all moving around. The reason I have this, if you're thinking about trying to navigate and you're moving around like this, that's rough. And you're in the middle of the ocean, you're going to have a tough time. So you can do latitude. And latitude is just the north or south. It's the bands that are parallel to the equator. Now longitude is a different thing. And that's the problem that they couldn't solve. It turns out that you can solve it if you look at eclipses of moons on Jupiter. And you can also look at angles with certain stars. If you're on a different place in the Earth, it's a little bit different. But you try to do that on a moving ship, you're going to have a really rough time. So if you were sitting someplace else on the Earth and you had some very careful telescopes mounted, you can actually do this. But not when you're on a ship. So the Royal Society in London was in charge of seeing, okay, so who is going to solve this problem? People had all kinds of harebrained schemes. Someone, though, realized if you had a really, really good clock, you could solve this. And what you would do is you would start in a convenient place like Greenwich, England, for example, where 0 longitude is. And if you knew exactly what time it was in Greenwich, England, you could be somewhere else in longitude. And you could see exactly when the sun hits its peak. And you could compare that clock that you have on your ship to that. You say, wow, it's 1 hour, 6 minutes, and 32 seconds. We know that we are this far over longitude. And this was solved by a mud bug, a guy that a carpenter, a commoner. And in the United States, we're all commoners, but that was a big deal in England. This guy was a carpenter from a podunk town, and Yorkshire and then Lincolnshire. And he had no formal education at all. He was a carpenter. He got interested in making clocks. And when he was making clocks, it was fascinating. He made all kinds of amazing innovations. He realized there was this wood from the Caribbean called lignum vitae, which means wood of life, that it was super hard and it was very strong and it had oils. It was super oily. So when he made gears for his clocks, they were naturally lubricated, and you didn't have to lubricate them. And by the way, to this very second, he has clocks that are still operating. 300-year-old clock, and they still keep good time. It's pretty amazing. He made a bunch of other innovations, and he started working on this. Here's the problem. You have a commoner with a unconventional way of measuring longitude. The Royal Society really was interested in looking at an astronomical solution. So what they did is they took his clock, locked it up in a box. He was on the ship with it, and then had the person to monitor it. And of course, that person was a member of the Royal Society, who was the other team, basically. So basically, you had a referee for the other team, and monitored it. And they went all the way to the Caribbean. No, it wasn't that far. It was Canary Islands, I believe. And they opened it up, and they knew exactly where the Canary Islands were because they had good astronomical observations, and it was within 10 miles. He did this in about probably 30 or something like that. And of course, he looked at it and he said, well, it was just a coincidence. Probably your inaccuracies here were canceled out by something else over there. And then they did it again. And then Parliament decided, well, you're a commoner. You're not you don't get the award. So it took the intervention of the King of England. He got his money. So it's one of these, gives you you're really satisfied. Now, how accurate were his clocks? The H4, which is the fourth one he made, 1 second per month. And I bet you almost no one here has a timepiece that's that good right now. It's amazing. Basically 100 times better, again, than any clock around. All mechanical. Here I show some what are called escapements, and I'm low on time here, so I need to go a little bit further, a little bit faster. But an escapement is basically a device that gives impulses to the timekeeping element of a mechanical watch or clock. But it's also powered by some sort of force. In this case, it's a spring that's wound up. And in this case, it's usually like a weight, which goes down over time and powers the escapement. Now, I'm not going to tell you all his inventions. The guy was a genius. And there is a wonderful Nova video. I encourage you to look that up. And one of the best stories I've heard in years. Okay, so again, navigation, GPS. So when you all think of GPS, you probably think of this, right? We used it to get here. We're all using this, and it's amazing that in the palm of your hand you can know basically where you are on the Earth within certainly 100 feet, maybe a little better. Some cases as good as 10 feet. But really, what you ought to be thinking of is that and that. So there's a series of about a couple dozen satellites that are about 10,000 miles up. And by the way, the International Space Station is 250 miles up. These are way up there. Why? Because it's hard to shoot it with a missile when it's up at 10,000 miles. You have to have a lot of technology to shoot those things down. So they're all going around, and they have an interesting thing inside them. They have an atomic clock. Now, I don't have time to talk about it in detail, but there was a wonderful innovation in about year 1927 invented called the quartz oscillator, the quartz watch, which was introduced by Seiko in 1969. And if you got a watch, it's a quartz watch, unless you're really fancy and have one of those mechanical watches. And if you have one of those super nice mechanical watches, you probably need to donate some extra money to AI. Okay? So I'm going to say that because those things are expensive. So, but usually you have a quartz oscillator. It turns out the quartz oscillator is generally far better than any mechanical, usually. Harrison's clocks were very special. But we also find out that we can make them better. If we take a quartz oscillator, and you all have heard of atomic clocks before? Well, basically, they're fancy quartz oscillators. They're quartz oscillators with a little oven and some cesium atoms that go back into the feedback loop and give a little extra current when you need it to give it a nudge to keep it keeping time. So the little clock on here loses 1 second every 130 million years. It's so good, you don't even think about it. I mean, you can't even imagine it. So how does this allow you to get to the clay pit from home? So imagine if you had a satellite and it's blinking a signal toward you. And you know exactly what that signal is supposed to look like. And it comes to you, you could know exactly how far away that signal is. But you don't know the direction. It could be here, it could be there, but you just know it's 14,000 miles away. But if you had 2 of them, well, then you could actually know where you are in a plane. If you had 3, you could know where you are on a line. If you had 4, you could know exactly where you were in space. And that's what we have now. The interesting thing is the speed of light. You hear 300,000 kilometers. 300,000 kilometers per second. The easiest way to look at it, speed of light travels 1 foot in a nanosecond. 1 foot in a billionth of a second. Okay? So these things are so accurate that your phone, because you hear all these guys blinking toward you, you have a timepiece in your hand that's accurate to within somewhere between 10 and 100 nanoseconds. Because you know where you are on the Earth between 10 and 100 feet. It's pretty amazing. So, super exciting. So, now we're going to the final part of the talk, and it looks like I'm going to be about right. Why is time? Okay? So, first part was about what do physicists think time is. And then we talk about our manipulation of time and why we do it and why it's important. And then the third part is, I think, the more important part. So, Genesis chapter 1, verse 1. In the beginning, when God created the heavens and the earth was without form or shape, with darkness over the abyss and the mighty wind sweeping over the waters. Then God said, let there be light, and there was light. So people always say, what's the first thing that God created? And they say, well, it's light. I don't think so. So I was reading this a while back, and I realized, oh, wait a minute. You can't have light without time. And they said there was a beginning. If there was a beginning, God had to create time before he created light. And I thought, oh, I'm a genius. And I went to a priest, and I said, look what I figured out. And he looked at it, and he said, yeah, that seems reasonable. And I thought, so smart. And as usual, when you think you're really smart and you figured something out, all you have to do is read Aquinas or Augustine, and then you realize, okay, yeah, they figured it out 1,000,000 years ago. So it turns out that St. Augustine said the same thing. And then there's someone else that I'd never heard of before. You ever heard of Tatian the Syrian before? Well, he lived even before St. Augustine, but he said the exact same thing, that God had to create time first. And so just like what the physicist said was interesting. It's like, there was nothing. Things were without form. Nothing was changing. Things were just like, bleh. And then something happened. Well, God created time, and then everything else happens. The funny thing is that physicists don't like to admit it, but the whole Big Bang or the creation of the universe, whichever you want to follow, kind of violates that thing called the second law of thermodynamics. It just kind of happened. That's what they say. And then everything after that would obey the laws of the universe. Well, so one thing I was thinking about is, why did God give us time? And I wrote a long meditation over this, and I'm not prepared to talk about it in detail right now. But it's a reasonable question to ask. Why was that the first thing that God created? Maybe another talk. But I want to read something as that you might touch you or may help you think about this a little bit. While I was writing a meditation on time, my 12-year-old daughter, who's now 19, was only vaguely aware I was writing on this subject. She came up to me with a neat observation. Imagine if your life were only 1 minute long. All you would have to do is be holy and follow God perfectly for that 1 minute in order to receive His grace. "12-year-old. And but wait a minute, isn't that really what we've been given? You know, to God, a minute or 100 years is the same. It's nothing. So I have a present for you all. And I can read it so you don't have to. You can continue eating if you like. But I have a copy of, if you all want a copy, you're welcome to it, or you can take it afterwards. Would you all rather look at it or grab a copy afterwards? Okay. So this meditation is called 2 Weeks to Live. This is the last part of the talk. We are all here on this earth for a finite amount of time. Usually we assume we have a lot of time left. This is demonstrated by the number of things we do that won't matter in a month from now. Perhaps you can identify several things you have done in the last few days that won't matter at all in a month. Have you ever wondered what you would do differently if you knew the end of your life were near? We are reminded of our own mortality when we go to Mass on Ash Wednesday, when we go to a funeral, or even when we are occasionally reminded of our aches and pains, waistline, or wrinkles that we're not getting any younger. Nevertheless, we've probably all thought about it at least a little. There are plenty of popular movies in which a person is confronted with their own mortality and realize they are near the end of their life. Naturally, they panic. In the panic, they may resort to reckless behavior, sex, drugs, gluttony, lavishness, or even a little revenge on their enemies. However, those are just movies. Have you ever thought about what you would do? The answer may reveal a lot about you and your current state of your soul. Perhaps if you think about it a bit, the answer might even change over time. First, a personal story. And I wrote this. This is my personal story. I had a close friend who died suddenly in his 30s of liver failure. He left a wife and 2 young children. As his wife was going over his belongings, she found hidden in the basement dozens of empty bottles of vodka, which undoubtedly contributed to his early death, along with a large collection of pornography. Unfortunately, this was not particularly surprising, but it occurred to me how difficult this must have been for her. Even more importantly, it was apparent to all of his loved ones that his private time was not spent preparing himself for God. This hurt me horribly, as there was nothing he could do after his death to atone for his sins. Because he could not, I pray for him and still do. So I began to wonder how my friend would have conducted himself differently if he had known 2 weeks earlier that he was going to die. Would he have done the same in a more grand fashion? Or would he have repented and changed his ways? This made me start to evaluate my state. I could be 2 weeks away from my death right now. Have I been living the life that I should be leading? More specifically, how would I lead my life differently if I knew I were going to die 2 weeks from now? When I did die, would my wife be ashamed and disappointed when she went over my personal belongings and computer files? Or would she beam with pride between her tears at what she saw, knowing that the man she married sought a life to be closer to him? Wouldn't it be fantastic if, after my life were scrutinized, that I appeared even better than what my loved ones knew me to be? Then it hit me. I should be living this way always, as the Bible is quite clear that we don't know when we will be taken from this earth. This brought up another question. Is it possible to live your life as if you have 2 weeks to live? Even if you have a reasonable confidence that you will probably live a lot longer. Could such a view be a tool to help attain holiness and union with Him? So consider for a moment that you have just received the results of a medical test, and your doctor has told you that you have 2 weeks to live. What are your thoughts? What do you fear? What are your greatest concerns? And I have a little place where you would write them down. No spoiler alert here. You can do this on your own later. After you get over the initial panic and have gone through the 5 stages of grief, denial, anger, bargaining, depression, and finally acceptance of the inevitability of your situation, think hard. How would you lead your life differently over the next 2 weeks? If the answer is no difference at all, then you're probably where the rest of us would like to be. Most of us, however, would probably lead our lives differently. So, if you happen to be in the majority, begin by making a list of what you will not be doing over the next 2 weeks. One thing for certain, you won't be buying any green bananas. There's not much of a point in doing your laundry. What about sleep? Nope. There'll be time enough for that in the grave. You'll probably stop contributing to your retirement plan at work. Wait a minute, you probably won't even be going to work. Unless you work for the Austin Institute. See, I have to get those plugs in there every now and then. Your favorite TV show? Nah. Faced with your impending death, it wouldn't seem like a priority anymore. There's probably much more. Pause for a moment and write down what you wouldn't be doing if you knew you had only 2 weeks to live. Again, a list that you can fill out. Now, the first list was what you're not going to do. That's only half of it. You need to make another list. What are you going to do? This might be more important, maybe the more important of the two. I know I might make a beeline to the confessional. And by the way, I have something to confess to you all. I went to confession yesterday because I'm thinking, I'm going to be reading this before you all, and I have to take the medicine that I'm giving out. So I went last night to confession. It may be the last time I get there. What about going to Mass? I can't say I'd be making any excuses for not going to daily Mass either. Adoration? Yep. What about material possessions? Would you give away any of your belongings or donate to that charity that you've been meaning to help, like the Austrian Institute? What about giving away all your possessions? Would you surround yourself with loved ones as well? What about burying the hatchet with friends or relatives with whom you once quarreled? Are there people that you've been meaning to contact that you really care about so that you could tell them? Do you have an old friend whom you've been meaning to catch up? Pause for a moment and write down what you would do if you knew you only had 2 weeks to live. So, and then I've got a list again. Go back and look at the last two lists again. How many of these items involve the secular world? How many involve intimacy with others and with God? This might tell you something more about yourself and what you truly value. Now I have a big question for you. If near the end of the 2 weeks your doctor calls you miraculously, and you miraculously find out that there was a computer error at the hospital, you received someone else's diagnosis and may actually have 50 years to live. Praise God. Now that you have regained your composure and prayed for the other person whose diagnosis you received, go back and review all three of your lists. Is there a way you can make the fears and concerns list have 0 entries? Of the items on your won't do list, which of those items would you resume? Which would you eliminate completely? Why or why not? That probably tells you a little bit about your state of your soul as well. Now consider the will do list. Which of these items would you regret given the change in the news? Why? Which would you be glad you did? Why? Could you consider doing those things over the next 2 weeks or even the next month? Were some of those items of a repetitive nature that could be developed into a good habit, such as going to daily Mass? Could you incorporate those into your schedule? Look back on your first list. As the 2 weeks drew to a close, would you have feared death or feared judgment? Our secular world teaches us to fear death, as it is the end. In contrast, our faith teaches us the immortality of the soul and that physical death is a necessary part of the process. We all will die, and we all will be judged. We may be able to affect when we die, but not whether or not it will happen. However, with judgment, we do have a great opportunity to prepare for it. So prepare for it. In a way, this short spiritual exercise wasn't really about preparing for your death at all. It was about preparing for your judgment. Unless you happen to be St. Paul, who went from murderer of Christians to servant of the Lord in an instant, it takes time to get your soul into shape. I would further wager that it generally takes a lot longer than 2 weeks. The proof may lie in the fact that if you realized you really had only 2 weeks to live, you would likely have a lot more to do than 2 weeks would allow. I believe that fear of judgment would place a desperation in our souls that we don't have enough time to do what we need to do. One of the aims of this document is that when the time comes, you happen to be lucky enough to know that you only have 2 weeks to live, you will be prepared to meet him. much of your life will be no different during that actual last 2 weeks. Of course, we all know it's a good chance that when we are living our last 2 weeks, we probably won't even know it. So, final slide, what is time? This is my thought. Time is the gift God gave us so that we could have the opportunity to reach Him. And that's my talk. Thanks.